Hello, this is Mrs. Heisey. This is Integrated Math 3, and I'm teaching how to solve 3 by 3 systems. A 3 by 3 system has 3 variables. That's where one of those 3's come from. We have x, y, and z. The x-plane, the gray one, is like the x-axis. The y-plane is the orange one, like the y-axis, to represent the y-axis. And then the z-plane is the yellow one, and that represents the z-axis to make this three-dimensional. So that's what we use for three-dimensional pictures. And this little point where they intersect is called the solution. And it's at the coordinates x, y, z. And that's called an ordered triple. Ordered triple is x, y, z, always alphabetical order. Okay, so this is an example of a 3 by 3 system of equations. They're linear equations because none of the variables have an exponent or under a radical. And it's 3 equations. So three equations, 3 variables is what I mean. And we need to solve this. What we're used to 2 equations, 2 variables. And we could just add the 2 equations, cancel out the y's there, and then solve for x and find y after that. This, not much different than that. This is actually very simple, but it does take a lot of paper, and you do have to be precise. So you have to really pay attention with your computation. What we need to do is we need to multiply, or not multiply, we're going to label these equations. We're going to call them 1, 2, and 3. And my pencil's probably a little hard to see, so let's try with pen. So equations 1, 2, and 3. Okay. We need to pick a variable to get rid of. So we could either get rid of the x's, get rid of the y's, or get rid of the z's. It does not matter which variable to get rid of, just pick one. I like the y's or the z's because this y does not have a coefficient, so that makes it easier to adapt to either of the other 2 equations. Z also does not have a coefficient, makes it easy to adapt. But these numbers are bigger than these numbers, so I'm going to eliminate the y's. To eliminate the y's, you need to just pick 2 equations, only 2 equations at a time. So we're going to pick equations, let me move the paper over here so I can reach it better. We're going to pick equations 1 and 2. We definitely want 2 because that one's easy to adapt. And then we'll pair that with 1. So 1 is kind of nice. We could just write it out the way it is. Okay, so we were able to just write that out. We didn't have to multiply anything. This one, we need it to be minus 3y. So in order to get this to be minus 3y, we have to multiply it by negative 3. We can't just multiply y, we have to multiply the entire equation by negative 3. So I like to put the parentheses around it just so I don't forget. The parentheses help me to remember I have to distribute that negative 3 to everything in that line. So this is our new equation 2. It's the same equation 2, we're just multiplying it by negative 3. So 9x minus 3y minus 15z equals 15. So now if you notice, we have plus 3y minus 3y. Our y's are going to cancel out. What we need to do is add the 2 equations. Those cancel out. And now we have this equation that has no y. It only has 2 variables, which is something we're familiar with. We're going to call this equation 4, fourth one we came up with. So we have the first 3 here and then equation number 4. But as you saw in this example here, we need 2 equations with the same 2 variables. So we need to get rid of y again. Since we used equations 1 and 2 first, then we need to use equation 3 and we need to pair it with one of the other 2 equations. Since we're getting rid of y, probably want to use equation 2 with it so that we can adapt this pretty easily. So we're going to use equations 2 and 3. That has a +2. In order to get rid of this, the y, this needs to be a -2. So to get this to be -2, we need to multiply it by -2. So here we already did -3. Let's multiply it by -2. And our new equation will be 6x minus 2y minus 10z equals 10. The third equation is nice because it already has the positive 2y, so we can just write it down the way it is. And now we add the two equations, and so we get, let's see, 2x there, the y's cancel out, minus 9z equals 23. We'll call that equation 5. New equation. So, if you look at equation 4 and equation 5, they both have x and z. We need to get rid of a variable. We could get rid of the x's or the z's. It does not matter which one. But I noticed the z's have the same coefficients. So since the z's have the same coefficient, they just need to be opposite signs. So I just need to pick an equation and multiply it by -1. And when I multiply that by -1, the new equation 4 ends up with a positive 9z. Equation 5 gets to stay the same because we need that to be negative 9z. There we go. So now we have z's that will cancel out. So I add my two equations. Z's cancel out. So negative 2x equals 4. So x equals -2. But we're not done, because we need an ordered triple, and this is only one number. We still have to find y and z. So if we plug in -2 in place of x in any of these equations, we'll still have variables y and z we have to find. So the best place to plug in -2 is in one of the two new equations, either equation 4 or equation 5. It doesn't matter which one you choose, either 4 or 5. I'm going to choose 5. So equation 5, I am plugging in -2 for x. So 2 times -2. So that's -4 minus 9z equals 23. So -9z equals 27. So I know z equals -3. But that's still not enough for an ordered triple. I still need to find y. So I can use any of these three equations. I could plug in my x and z and find y. I'm going to use the middle one because y does not have a coefficient. So let's move this up a little bit. We're using equation 2. Plug in my -2 for x. My -3 for z. So here I get 6 plus y minus 15 equals -5. So y minus 9. So that makes y equal to 4. So y equals 4. But of course, that's not how I write my answer. I've got to have my answer as an ordered triple. So we do x, y, and then z, always alphabetical. Whatever three letters you have, always put them in alphabetical order. This is my official answer solution. But just to make sure it's an answer, it's only a solution if it works in all three of the first three equations. It does have to work in all three of them, not just one, not just two of them, but it has to work in all three equations. So you can plug this in mentally. I'll write down a little bit, but -5 times -2 is 10. 3 times 4 is 12, so plus 12. 6 times negative 3 is minus 18, and 10 plus 12 is 22. Minus 18 equals 4. So this first one checks out. Checking equation 2, negative 3 times negative 2 is 6, plus 4, which is y, and then 5 times negative 3 is minus 15. 6 plus 4 is 10, minus 15 is negative 5. So equation 2 checks out. Checking equation 3, negative 4 times negative 2 is 8. 2 times 4 is 8, plus z, which is minus 3, equals, well, that's 16 minus 3 is 13, which matches there, so checks out. So this solution is a solution for all three equations, and that's what we're here to find out. So have a good day, get your homework done, bye.